for the positive or negative tangent of pi over 6. We should know the tangent of pi over 6. That's one of them that we have to start memorizing. That is our first tick mark. That is square root of 3 over 3. Once you have that memorized, you wouldn't even need to look at your unit circle, or you just have to have that first quadrant filled in. Now, the last part of this, let's say this is a 3-point question. That's 2 points right there. You get a point for your positive or negative. So if I'm stuck on a test, I got a 50-50 shot on this, at least. Well, let's get it 100% correct, so I want to figure out if this is positive or negative. To do that, I have to know the quadrant. Well, 41 pi over 6 is not on my unit circle. It's way too big. So I'm going to subtract 2 pi. Well, 2 pi doesn't have a common denominator, so I need a common denominator of 6, which will actually make this 12 pi over 6. If I did that once, would that put it on the unit circle? No. I should end up doing it, 3 times?
Yeah, I think so.
Pi over 6 minus 12 pi over 6. 3 times because that would be 36. And that would leave me with 5 pi over 6. Can someone describe how I automatically know that's quadrant 2?
Because it's the 5 over 6. It's like one less.
It's one less. I think Lewis was going to say the same thing. You just stole it from him. He just actually raised his hand. That's okay. You were just excited about the answer. All right, I am in the second quadrant. We have to remember all students take calculus. All of them are positive. I'm in my second quadrant. That's students. That means sine is. What else is positive? Sine and. Nope, you guys are. I'm thinking about positive. Cosecant.
I'm literally thinking about. I'm actually. That's me.
Sine and cosecant are positive. So remember, sine is positive because that's what all students points towards. Cosecant is positive because all you do is you flip the fraction. So is tangent sine or cosecant? No. So that means it's negative. We're in quadrant 4, which makes it negative. So this is going to be a negative square root of 3 over 3. It looked like we were torn between these two. The correct answer is D. The correct answer is D, not A. It's D. Negative square root of 3 over 3. Let's go back to the beginning. Cosine of pi over 2, that's from our original unit circle. What's the cosine of pi over 2? 0. As a reminder, that's actually 0 over 1. Thank you. Because when we do the next part, that's important to recognize. There's 2 ways to remember this. First way, well, the reciprocal of 0 over 1 is going to be 1 over 0. Which is undefined. The other way I remember this, if you take the reciprocal of undefined on the unit circle, this is not a mathematical rule, it's a unit circle rule. If you do the reciprocal of undefined, it becomes 0. If you do the reciprocal of 0, it becomes undefined. So remember, these cosecants and secants have undefined places. That's going to be important today for graphing. Questions on any one of those 3? Go.
It's only undefined on like the 90.
Yes, it's the only place you have to worry about. Even for tangent and cotangent, it's always the y or x-axis. That's a good point. I do want to quickly point out that our quiz on kind of this stuff will be not. I see you tomorrow, right? I don't see you tomorrow. If you remember, I'm not going to be here. You will have a sub. You will have a video. It's already online where you normally check your answers. So your job in class is to just watch that video and do the homework. After that, the next time I see you will be a quiz. It'll be a quiz on reading the unit circle. It will be graphing cosecant and secant, which we'll do today. And we'll also graph either tangent or cotangent. Now, I'll tell you, you'll watch the lesson tomorrow. I'll show you how to do shifts left and right of it. That's basically an up and down a little bit. All you're going to have on the quiz is it's just going to say graph a basic tangent or cotangent. So you don't have to worry about manipulating it because I'm not here, so I'm not sure how much we're getting, but we should at least be able to draw a tangent graph basic or a cotangent graph. It really is just doing this or doing this. It'll be one of 2. Okay. Questions on the homework? Yeah, I got a question on the last 2. Cool. Let's go over the last 2. That was a good question, whoever. Yeah. Good job, Lewis. All right. I'm going to do 19, and I'm going to let you do 20. 19 says, I want the secant squared of 2 theta. Don't get bogged down by theta. Theta is just a variable. It's just like me putting 2x. So anytime you see theta, think of x, y, a z, or anything like that. It's just a variable. It's a holding place. But then it gives us more information. It says that if theta equals, I guess, pi over 6. Well, if this was an algebra equation that says 2x, where x equals 4, you would take 4, you'd substitute it in for x, and you'd be 2 times 4 is 8. That would be the end thing. That's exactly what we're doing here. It's just telling you, hey, theta equals pi over 6. Well, take theta and plug it in for theta here, just like you would if those were x's. If this had 2x and x equals pi over 6, you'd plug pi over 6 in for x. We're doing the same thing for theta, which is going to give us a new equation. It's going to say, oh, okay, all of that equals secant squared 2 times, well, now I know theta equals pi over 6. Now, I don't know about you, but 2 pi over 6 isn't quite on the unit circle, so I simplify it. We could even rewrite this a little bit. You don't have to do this step if you can see what's happening here. But I basically have 2 pi over 6, because we're multiplying 2 times pi over 6, so I have 2 pi over 6, which would simplify down to secant squared pi over 3. Now we're going to notice we're at pi over 3. Pi over 3 is on my unit circle, but it's got this dumb little squared thing here. Now let me refresh your memory of how you square like secant signs or anything like that. The way you should actually picture this, and I'll tell you why we do it this way, but what we're actually doing is we're finding the secant of pi over 3, and whatever that is, we are going to square it. Now, we normally put the square where it is, right above the secant, so we don't have to write brackets and put this over here. But it means exactly the same thing. You could picture what happened if we didn't do this. So if you just kind of pay attention here, notationally wise, if I'm doing a big proof on several pages and I put it squared right there, all of a sudden that squared all of a sudden falls into the pi over 3, and I'm squaring the pi over 3 and not the right thing. So to prevent us from doing that, we put the squared there. But you'll notice on my answer key a lot of times I'll rewrite it so we can see the square happens on the outside. So they're just asking you to find the secant of pi over 3, and whatever you get, square that answer. Secant, I'm thinking cosine. Secant goes with cosine, so when they tell me find the secant of pi over 3, the first thing I'm going to do is I'm going to find the cosine of pi over 3. Now that's either going to be square root of 3 over 2 or 1/2. It is going to be actually 1/2 because it's our third tick mark. Sine would be a 3, so cosine would be a 1. Remember, I always remember sine. Sine goes 1, 2, 3, which means cosine would be 1 out there. So this would equal 1/2. You have to flip it. Thank you. So we flip it and put it in here. So we're coming right back up here, but that means I need to flip it as 2 over 1 squared. Well, that's really just 2 squared, which is the old quattro, the 4. Is that enough for you to try the next one at least? I want you to at least try one of those. The answer key has it all worked out as well. So if you get stuck, if you're like, I'm not sure of it, you can go there. All right. What other questions do we have from this homework? Besides that brilliant question in the last 2. Okay, then I will not pause for effect because I want to get through as much of this as we can. Oh, we'll get through all of it. So this is important because this will be on that quiz. And I don't think this is really hard because hypothetically you can all graph sine and cosine right now. I'm just asking you to change those graphs just a little bit. So when I ask you to graph cosecant, I need you to remember sine is its brother. So if I ask you to graph cosecant, the very first thing you're going to do is you're going to graph sine instead. That's it. You're just going to graph sine. We're going to add stuff to it, but sine is going to be our starting off point. So the basic graph of cosecant, first I graph sine. Now this won't be our finished graph, so I highly suggest you just do like light dashed lines or don't even finish it. So what I mean by that is you should know at this stage that sine starts at 0, 0. It goes up to 1, goes back to the sinusoidal axis, goes back to -1, and then goes back to the sinusoidal axis. Now what you can do here is just stop. If you're like, I can picture that graph as sine, awesome. Just stop here. You got the major points. If you're not so sure, just put like little dashed lines that go up and down. I'm just going to put a little arrow that says, you know what, that's sine of x. That actually has nothing to do with my final answer. It's just going to help me get my final answer. All right. Now, our bell work prepped us for this. So there's places on the unit circle where sine equals 0, right? Like if I ask for the sine of 0 degrees, you'd go, oh, the sine is 0. Well, if sine is 0, what's cosecant's value then? If I do the reciprocal of 0, I end up with undefined. So here's something you need to realize is that anytime sine is on the sinusoidal axis, I'm going to use sinusoidal axis because if you can picture this, if I shift this up one, it's still the sinusoidal axis that I'm looking at. Anytime your sine hits the sinusoidal axis, you have an undefined place there. Now, if you remember from algebra, undefined usually means that we have to put some kind of asymptote there. We could do like a circle, but I'm going to do a dashed line to let myself know that it's not going to hit there. And you'll see why I don't do a circle. So this is specifically for cosecant to say it's undefined at these places. Those lines let me know that it's undefined, undefined, undefined. Would there be more of these?
Yes.
How many more are there? There's an infinite number. Am I going to draw all of those? No. But I do want you, yes. I'm going to spend the rest of the class just doing an infinite number of vertical asymptotes. That seems like a good day. All right, so I want you to know that this repeats itself. Was that hard so far? You graph sine, you put vertical asymptotes where it hits the sinusoidal axis because it's undefined. You have one more step. Whether you know this term or not, do you realize that this is concave down? In other words, this is facing down. From this asymptote to this asymptote is like a hump that's facing kind of down. We're going to flip the direction of it. So if it's concave down, we're going to make it concave up. Now, here's what happens with those asymptotes, and this is why I didn't just do a circle. When I flip this bump up, we're going to put arrows saying it gets close to those lines, but it never reaches them. So your cosecant will not reach the other part. It'll actually be separated. Because if you look at this next mound is concave up. To flip that mound, I'm going to go concave down. So my cosecant is going to look like this. Now, I want to note you need both of these. You need both to do one full cycle of cosecant. You can't just show me a top one, a bottom one, because what's going to happen next is this is going to repeat. Repeat, repeat. It's just going to keep going up and down forever. Do I want you drawing up and down forever? No, I just want one cycle. This is one full cycle of cosecant. But as long as you did sine first, you don't really have to remember up and down. You just have to graph all of what sine did and flip both bumps. That's it. If you know how to graph sine, you remember cosecant goes with it, it's not a hard process. It is vertical asymptotes, flip the bumps. What can be a little more difficult is, let's cover a couple small nuances on this. The period of this is still 2 pi. But we have some problems with range and, not problems, that is a little more difficult to do range and domain. Range is how low to how high the graph goes. Well, how low it goes isn't so hard. How low would I have to reach down if I kept my finger on this portion of the graph? I have to go down for infinity. So we start at negative infinity. Cool. Now, I go up, I go up, I go up. At any point, do I have to lift up my finger to get to the other one? Yes. So here I lift up. I have to lift up my finger at -1. I have nothing that connects it up here. So I have to lift up my finger at -1 and put it back down at 1. So it's negative infinity to -1 with a bracket. Does anyone remember the symbol for if I have to connect two of them, Lewis? The U. You just threw your voice to like 5 different people. And then I put my finger back down on 1, and then I go to infinity. Domain's a problem. Domain for sine and cosine, easy. Negative infinity to infinity. But here, can I go from negative infinity to infinity without taking my finger off the graph? No, I have to keep picking it up and putting it down, picking it up and putting it down. So basically, I have to go from 0 to pi, lift up my finger, pi to 2 pi, lift up my finger, 2 pi. So at those points, I don't know who wants to write it like that, because it's going to take an infinite amount of time. So we're going to do something instead. I'm going to look at where the asymptotes are. I'm going to come up with an equation for where the asymptotes are. There's a really easy way to do this, and there's a hard way. Let's do the easy way. The easy way is first get the distance between your asymptotes. It should be a fixed distance. Is there a fixed distance between all of our asymptotes? Yeah. How far is it? Pi units. The distance is pi units between each of these. So I'm just going to go ahead and write down pi. That's the start of it. I'm going to call this distance. It's the distance between our things. Now, if I want to keep repeating something, I'm gonna multiply it by a number. So if I want to go 5 pi from here, I'd multiply by 5. I want 5 pi steps. So what I'm going to do is I'm going to put a k there. K is going to be an integer representing that I can keep multiplying by pi to get to all of them, since it's an infinite number of them. We do need one more step. I need to add the location of the first vertical asymptote. So this is kind of the location of the first vertical asymptote. I'm just going to say, where does it start? It would be 0. So we're just going to say plus 0. So it wasn't really needed on this one. So really our formula is k times pi. Let's see if it works. If k is 0, do we have one at 0? Okay. If I make k 1, do we have 1 at 1 pi? If I make k 2, we have 1 at 2 pi. So that means 3 pi, 4 pi, and I go negative with it. Negative 1 pi, negative 2 pi. That accounts for all of them. So now we can go to the domain. We can say domain is all real numbers, except x cannot equal k times pi. That's the easiest way to write that. All real numbers except x cannot. Make sure it says cannot. I've seen people just put it equals to, which means that doesn't make any sense. Which I'm looking for? Here? Oh, that's my boldface R. It's my... this will look better. Does that look better? Not an I. It's actually a boldface R. It stands for all real numbers. It's the same thing as putting negative infinity to infinity, just quicker. Remember this starting thing, because we're going to need that for cosine. Well, secant, really. All right, our next one is, questions on this one before I move on. Okay, secant. If you know how to do that one, this one's easy. Secant is just graph cosine. Vertical asymptotes at where it hits the sinusoidal axis. Flip the bumps. The only difference is we have half bumps worth cosine. Because cosine normally starts at 1, sinusoidal axis, negative 1, sinusoidal axis, up 1. Make a little note saying that's just plain cosine. That's the sound it makes. It's not my fault. That was the iPad. Once again, our next rule is put vertical asymptotes where it hits the sinusoidal axis. In other words, where are those middle points? It's pi over 2 and 3 pi over 2. So we should put vertical asymptotes there. So vertical asymptotes at pi over 2 and 3 pi over 2. Vertical asymptotes, check. Next step, flip the bumps. Now, sine had complete bumps to flip. Cosine has one of them. So if you look at this middle one, if I flip it, it's going to look like an entire mound got flipped. So let's do that one first. Now, the other two are just half mounds. So I should just flip half the mounds, which are going to look something like this. We should be smarter than what the graph looks like. We should know that these are actually complete mounds. I'm just drawing half of it. I'm just drawing half of this one, because just like sine, this is a down, up, down, up, down, up, down, up, down, up. I can't go any further than that. But it continues forever. That is my secant graph. Let's handle some information. The period remains the same. It is still 2 pi. Our range, did that change at all? Does it still go down to negative infinity? Do we still have to pick up our finger at -1? Put it back down at 1. So our range is the exact same. It goes all the way down to negative infinity. You pick your finger up at 1. And we union that with 1 to infinity. Our domain is slightly different, though. Do we have a vertical asymptote at 0? No. So I can't do this. It's close to the same. Let's come up with the vertical asymptotes. Vertical asymptotes are going to be k times the distance between your vertical asymptotes. I just got to, okay, how do I get from pi over 2 to 3 pi over 2? I add a whole pi to it. So this is still pi. But the distance alone doesn't work because this tells me I could put a 0. Is there one at 0? No. Is there one at 1 pi? No. 2? No. Everything needs to be, it's got to be shifted a half pi. So that could be I subtract half pi, or I find the easiest way is just locate your first vertical asymptote. Where's the first vertical asymptote I drew? Pi over 2, that's the easiest way to do it. Just find any vertical asymptote and just put that number there. Pi over 2, that is the start.
Wait, how come pi over 2?
Because that's the very first vertical asymptote I drew. Now, I want to stop there. Yeah?
Is it plus pi over 2? Like, it's not like minus like the
It could be. That's what I was going to go into next.
Okay.
Can we all pay attention really quick? I just showed you a very quick way to do this. That is not the only equation for this. We would have a vertical asymptote at negative pi over 2 as well, we said. I could have put a negative pi over 2 and I'd have the exact same equation. In fact, not to hide anything from you, I can actually put any vertical asymptote. I could put 3 pi over 2 instead of pi over 2. If you check the math, it works. It's just traditionally for math, you pick the closest one. You pick the closest one to 0, so I don't have to go, 108 pi over 2. Let's make sure it goes all the way back to 0 like it's supposed to. So that's why I was just saying, get your distance, get the closest one. Get the closest one to 0 that you see. But you can technically pick any of them. I won't take any points off. If you said it's 3 pi over 2, good on you. I might on your test circle and say pi over 2 is a little better. There's good English, and then there's bad English. It's kind of like, that's a bad mathematical thing, but there's nothing wrong with it. It's just a little staccato-y. It's not as, a little weird for anyone that like studies this stuff. Okay, so that means our domain is going to be all real numbers. Still not a good one, is it? Still kind of looks like an I. But x cannot be, and we have to give the entire equation, k times pi or pi times k, your choice, plus pi over 2 or minus pi over 2 or plus 3 pi over 2. Whew. Are we okay on those? Yeah, almost had a question. Oh, okay. Is a mic drop with the pencil? All right, so let's handle this first one. Now, I like to show you different ways that people write things, but I typically write it the way that I like it. I like these with brackets around it. So I'm going to put brackets around that 2 and the x minus pi over 2. Now, as soon as I see cosecant, you need to think the word sine. And what we're going to do is, instead of graphing cosecant to start off with, we're going to graph the sine of 2x minus pi over 2. Vertical asymptotes, flip the bumps, and you're done. So you're doing everything you did on the most recent test, except now you're putting vertical asymptotes and flipping the bumps. That's the only thing we're adding to it. All right. If all of this is the same, we're going to gather the same information the same way. Period. That's 2 pi over b. What's my b value in this one? 2. Does it have an amplitude change at all? Nope. So it's just our amplitude, our period is going to be 2 pi over 2, which equals pi. I'm going to note the amplitude is just 1, just for a reminder that it just comes from that number out front. As soon as I have the period, I usually skip to 1, 2, 3, 4 pi. 1, 2, 3, 4 pi. Half multiplied by 3. Pi is not as hard to deal with. But a real quick way is, remember, half of that would be pi over 2. Half of pi over 2 is pi over 4, because we multiply by 1/2. Then we multiply by 3 to get 3 pi over 4. I'm going to do the rest of these, just because I don't do it a lot, but it's nice to see it. If this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, this is 5 pi over 4. Oh, I put a 6 for some reason. Our last one would be 6 pi over 4, which would probably be better if we write it as 3 pi over 2. So it's real easy. If ever I add that we have to keep, I'm not adding that, but if anyone did, it's an easy way to get all the rest of them. All right, and then I'm going to label my y-axes. No reason to lose a half point because we don't mark these. Hint, hint, people in this class. Okay, I should talk about shifting. Notice it doesn't say what kind of shift it does, so I have to list left, right, up, down. Does it go up or down? No. Does it go left or right? And it goes left because it's negative, right? Oh. It goes right. Oh, yeah, it goes the opposite direction. It goes right, pi over 2. Asymptotes, we'll worry about that after we're done drawing the asymptotes. You know how good you are at graphing. So you can go right to the end of sine, or maybe you can stick with me. I'm going to graph basic sine first because there's no amplitude change. Sine usually starts at 0, 0, goes up to 1, back to the sinusoidal axis, down 1, up 1. The only thing I have to do to this is I have to shift it right. I have to shift it right pi over 2 units. So 2 kind of tick marks, right? So I'm going to shift that over that far. And when we get good at this, me shifting this over, I just have a start point. Now I know it goes up, down, down, up. Or you can shift every point, however you feel comfortable doing it. So I'm just going to continue on. So it goes up, down, down, up. I am not going to connect these. You can. These are your notes, not mine. I'm not going to connect them because I can picture the sign, and I did it right, I shifted it right. It's not flipped or anything, so I can picture this being correct. I'm just using this as a reference to get my vertical asymptotes. Where is the very first vertical asymptote I should draw at? Pi over 2. Are there any other ones? Pi and 3 pi over 2. So I have all these hit the sinusoidal axis. Now all I have to do is flip the bumps. I wanted a bigger line than that. I do like people that connect these because you can see the bumps. I just don't because it makes my drawing look a little more confusing than it has to be. But I do like when you connect those bumps, you can see the bump being flipped. So whatever makes sense to you. All right, now we're supposed to list the asymptotes. Now remember, we have to first get the distance between our first asymptote. It's pi over 2 this time. That distance is pi over 2. It doesn't have to be positive or negative because we're just going to use the pi over 2. So what we're going to do is we're going to say, well, we're going to multiply, we'll just keep it going really big, k times pi over 2, or k pi over 2. I'm going to knock this down a size. So this could be k pi over 2 as well. Now we have to, so that's our distance. Now we have to put our first vertical asymptote. There are 2 answers. There's actually one that's better than the other. Well, actually, there's an infinite number of them. There's a clever one, and then there's, what's the first vertical asymptote we wrote? Pi over 2. So we can just put this as plus pi over 2. You got it correct. Here's what I am looking at. Is there one at 0? Yes. There's one at 0, so I honestly would put 0 is a better answer, but I totally understand why you'd put pi over 2. They'd both be correct. It's just one's easier to work with, k pi over 2, versus if you have to do an equation with it, having to do that stuff. Didn't ask for the domain or range, but we should recognize our range goes from negative infinity to negative 1. 1 to infinity. Our domain is all real numbers except for k times pi over 2. Questions? Now's the time to ask. Don't go, I have no idea what just happened in this class. We're okay? Yeah. Our do you not always come back? All right. We have secant for our next one. Rather than secant, I'm going to graph cosine with all of the changes that are supposed to happen. So what I'm picturing instead of secant is I'm picturing 2 cosine x minus pi minus 1 with all of its glory. I'm going to add amplitude. If this was on a test, you wouldn't have to, but it's nice to state it. Our amplitude should be 2. Can amplitude ever be negative? No. That number can be negative, and it tells you to flip it, but your amplitude has to be positive 2. All right, period. There's no number in front of x. Yeah?
Would if your secant was negative, would you even flip the mounds?
Yes. Well, yes. So we'd flip the cosine. So your mounds would be going a different direction for cosine, which means the mounds for the secant will be flipped. Let's talk about that after I graph it.
Okay.
Let's see what it looked like. So Lalo's asking, what would happen if I had a negative? How do I flip a flip mound kind of thing? And we'll talk about that. Remind me if I don't go over that. All right. But the period should be what? 2 pi over 1?
Yes.
Which equals 2 pi because there's a 1 in front of our x. We should go left pi because it's negative. We should go left pi because it's negative. We should go right. It goes the opposite direction, we think. Well, that means it goes up because it's negative 1.
No.
Oh, it only goes opposite if it's inside the parentheses. If it's outside, up and down, it goes the direction we think. So it should go down. All right, now we're just worried about cosine. We have 2 pi, so 1, 2, 3, 4, 2 pi. Half pi. Pi over 2, 3 pi over 2. I could continue to write things 1, 2, 3, 4. I could have 5 pi over 2. I could have 6 pi over 2, which is really just 3 pi. I'm going to go 1, 2, 3 on the y-axis, negative 1, negative 2, negative 3 on the y-axis. I'm going to graph cosine. I'm going to do it in 2 steps. I'm going to first graph cosine with an amplitude of 2. That means I have to know where regular cosine usually starts. Does cosine start at 0, 0? No. It starts up then, right? And now that it's 2, I'm going to start at 2. So it goes 2. I'm not doing all the shit. I'm just doing 1. I'm just doing amplitude, guys. So it goes 2, sinusoidal axis, down 2, sinusoidal axis, up 2. Now, I have to do 2 things with all these points. I have to move it right, pi, and I have to move it down 1. So if you look at that very first point I have, that needs to go right pi and down 1. This is where I would draw my sinusoidal axis. Your sinusoidal axis is no longer at 1 or at 0. It's going to be at negative 1 because we're dropping 1. So I'm going to draw my sinusoidal axis down 1. Let's stop here real quick. Would you be okay if you moved every single point pi and down 1? Yeah. You get the same graph. I'm just showing a slightly quicker way. You know you start here and your amplitude is 2. Cosine always goes up or down. We go back to the sinusoidal axis. We go down wherever the amplitude is. The amplitude is 2, so I go down here. Sinusoidal axis and back up here. Now I might just do a very light dashed line just to show my finished graph. Does that blue graph look like a cosine graph? Does it look like it dropped 1? Does it look like it went right and down? I did both, yes. It's a very easy way just to check to make sure it holistically looks right. Now here's where this is where people make mistakes when they use the wrong terminology. Because in your head you might have said, well, I put vertical asymptotes where it hits 0. Which would look like I put a vertical asymptote somewhere between pi and 3 pi over 2, and then between 5 pi over 2 and 3 pi, but that's not correct. I said you put vertical asymptotes where it hits the sinusoidal axis. It hits the sinusoidal axis at 3 pi over 2, and 5 pi over 2. So those of you that have been doing your sinusoidal axis, this is an easy adjustment. But people that aren't, draw your sinusoidal axis so you know where to put your vertical asymptotes. So in this case, our vertical asymptotes, I already used red. I guess I can use a thicker red. Our vertical asymptotes are going to occur here and here. I will now use black to draw my finished graph. My finished graph is going to look like this. Let me finish this and I'll get to Lalo's question. All right, asymptotes. Where's the very first asymptote? Or what's the distance between our asymptotes? That's why I kind of put, I have 3 pi over 2 and I have 5 pi over 2. So that would be, what, 2 pi over 2s, which would just be pi. So our distance is pi. So our asymptotes happen at k times pi plus either pi over 2, because we wouldn't get to 0. So we could put pi over 2. We could put 3 pi over 2. We could put 5 pi. I'm going to put pi over 2, but you put what makes more sense to you. If you're like, I'm going to study this when we take the test, and I'm not going to remember how I got back here, then just put 3 pi over 2 in your notes. These are your notes. I'm going to put pi over 2. Because there would be a vertical asymptote at pi over 2 if I just kept going. Is that clear kind of how I got back there? Remember, these are your notes. You need to put in there what you need to study. All right, then I had a great question about what would happen if it was negative. If this was negative secant, I would have graphed a negative cosine. So if you kind of picture that, I would have started down here, which would have also flipped this. So if this was negative, let me go ahead and do that in purple. Purple would look like this. That purple would be a negative version of this. See how all of those got reflected like cosine would get reflected if it was negative. Does that make sense on why you still have to flip the bumps, but you flip it in an opposite direction than you would over here?
That makes sense.
Okay? It looks a little confusing. I do want to get rid of those purples, but I hope that made sense with that drawing. Yeah, go ahead. Questions on that? All right, this is really just practice writing equations. If you're weak at doing that from information, you might want to try these. I will put the answers up for both of these. I would like to be able to get started on the homework and go over the test just a little bit. So I will put these answers down if you want to write them down and check to make sure that you get the same information. So your first equation should end up being 3 sine 3x minus pi over 4. No, I'm asking for, it's a straight up review. I asked for a sign. It says sign on it. Yeah, cosecant. It's fine. I got you. Our next one asks for a cosine graph. That cosine graph would actually be 2 cosine 2 x minus pi over 2 plus 4. But once again, write those down. If you have time, look over how you get those. It's good practice from given information to come up with an equation for it. Snag there. Because we'd actually have, and let's go through that real quick, because we would have pi over 2 equals 2 pi over b. And so we'd end up having 2 over pi times 2 pi, which would equal 4. Thank you.